Now, let us assume this, right? So this is fine. Now, assume that when it comes to this data set of vehicles with and without additive, right? And okay, let us read this. Effect of fuel additive on vehicles is being studied. Out of the 20 vehicles, 10 vehicles are randomly chosen and mileage is recorded. In the rest of the 10 vehicles, additive is added. We need to find if the mileage increases by adding the fuel additive. Okay. Assume the same data was recorded if only 10 vehicles were chosen and mileage was recorded before and after adding the additive. Right? What does that mean? If only 10 vehicles were chosen and on these 10 vehicles you are first testing the mileage, capturing the mileage, and on the same 10 vehicles you're adding the additive and then measuring the mileage, right? So if that's the case, then it means that the external conditions are the same. But even before we proceed with the external conditions, we need to check for normality, right? And we have already seen that with additive is non-normal. It is not normally distributed. So assume that during your analysis, you found that one value was wrongly keyed in. And that was the first data point, assume. So since the data was not normal, the cause of non-normality was investigated and it was found that first data point for with additive was wrongly entered and this value was supposed to be 20. We will replace it with 20 now and then try to proceed with the analysis. Once we replace it with 20, we need to once again check on whether data truly follows normal distribution or not. Yeah. And if the data were truly non-normal, our analysis would stop here. Okay. Say we have done this check. We will go back and we'll go here. And with additive, instead of 16, I'm going to change it to 20. After changing it to 20, we need to perform normality test. So we'll go back here and we'll perform the normality test. And we know how to write for normality test. Here, let me write it down, normality test. We need to write down null and alternate hypothesis. Null hypothesis says data are normal. Alternate hypothesis says data are not normal. So we have already seen in this data set that without additive is anyways normal. So let us test for with additive now. So I go to stat, basic statistics, normality test. With additive is anyways there, so let me click on OK. Okay, now things seem to be different. Now data points kind of are falling along the straight line, but we'll rely on the p-value. P-value here is 0.167. So p-value is 0.167. This p-value is greater than 0.05, which implies that p-high null fly, meaning we fail to reject null hypothesis. So data are normal, right? And there is another way of dealing with this normality. So you can simply go to stat, basic statistics, and click on graphical summary. Select the variable of your choice and click on OK. And these are the two ways of navigating. Ultimately, we'll get the same p-value, 0.167. We got 0.167 even using normal QQ plot. So that's not where we have to focus. We have to focus on the analysis and the final interpretation part. All right. So we will go back to this. So the external conditions are the same. If the external conditions are data are normally distributed, right? Yes. If yes, you need to proceed further. Are the external conditions the same? Yes. We assume that the same set of 10 vehicles were used and mileage was captured before and after adding the additive. So we need to proceed with paid t-test. And how should we write for paid t-test? The null and alternate hypothesis. We'll try to understand that. Okay. So here is a paid t-test. So let me choose a different color. So we are trying out now paid t-test. We need to once again write null and alternate hypothesis. Null hypothesis says average mileage with additive is equal to average mileage, without additive. Average mileage with additive is equivalent to average mileage without additive. Now, we need to write down alternate hypothesis also. Right? So mileage is same for with and without additive. And the next thing is, do you think, of course, if this is equal to the other one would be not equal to. Average mileage with additive, is it not equal to average mileage without additive? So let us try this. I'll go to the worksheet. We need to navigate to basic statistics, and you have the paid t-test. Each sample, yes, of course, is in its own column. If I click on this, I get without additive and with additive. Let me see the options here. Yes, difference is not equal to hypothesized difference. So let me click on OK. There we go. The p-value here is 0.06. Okay. P-value is 0.06. Is this greater than 0.05? Oh yes. What does this imply? This implies that, once again, P high, null, fly. Meaning, you fail to reject this. So mileage of the vehicle with and without additive is the same. Don't take any action. Alright. We can also try out a two-sample t-test. Right? Along with paid t-test, you can also try out two-sample t-test, provided you do not have this assumption. If we assume that the same data was recorded if only 10 vehicles were chosen and mileage was recorded before and after adding the additive, then yes, we need to perform paid t-test. But however, if this assumption is not there, we proceed with two-sample t-test because data were normally distributed.